Hello everyone and welcome to the Phenomenex video tip series. My name is Lucia Estudiante. I'm a senior technical specialist with the Global Technical Support team, and today I will be answering the question how to select the right C18 chemistry for my peptide mapping analysis. Now, the typical stationary phase used for peptide mapping is a C18 column. But not all C18 columns are the same, and we should suggest three variants of C18 that are our top choices when exploring peptide mapping separation. Our first choice, which is the workhorse in the lab, will be the XB-C18 chemistry. This contains a core shell particle with C18 ligands and carries a bulky diisobutyl chain. So these diisobutyl chains have two main functions. The first one is to protect the analytes from undesirable electrostatic interactions that can happen with the particle surface. But also the bulky nature helps when we are adding that ligand into the surface of the particle. In a way, is helping space those ligands through the particle and allowing for a more effective interaction for longer peptides. So longer peptides can fit better and interact better with the alkyl chains. So this type of column, the XB-C18, offers a more balanced performance, for most peptide characteristics. Now, the second and third column choices are always modified C18 chemistries. The Biochem peptide polar C18 is a fully porous thermally modified particle, and it has added polar groups in the end capping. Now, this provides a stronger retention of polar peptides, and it gives you that edge when you are dealing with difficult hydrophilic small peptides that may not retain in a typical C18. Then we have the PS-C18 that is also fully porous thermally modified particle, but in this case it has this positively modified surface. And it can do a fantastic job when you are dealing with basic peptides that perhaps in a typical C18 column were giving you bad peak shape and tailing. Now here you can see that for a digest of an ISMAB, these three columns were used, and there are differences in elution between these. So even though they are all C18 chemistries, we can observe a bit more retention for the polar C18 column and better peak shape for certain peaks in the case of the PS-C18, the positively charged surface. So clearly they are, different chemistries to explore. Now let's look at the advantages of the positively charged C18s. Particles. In that case, we have two main benefits. As we were saying, we can have better peak shape for basic peaks, and that's an example that you can see here, where the tailing is less when we are using a PS-C18 column. And we can see that in a set of different basic peptides in a mixed digest, like we were showing earlier. Now, the second thing in which a PS-C18 column can make a big difference for you is when you're looking at the amidations. Why? Because these deamidation variants are going to be more acidic than the non-deamidated form. And that means they're going to be somewhat negatively charged, and they can interact differently with the stationary phase. So in the case of an XB-C18 column, we may not be able to separate these deamidated forms, but when we are using a PS-C18, we can see a slight separation of the different peaks, which is sufficient to really have them separated and analyze them by mass spectrometry. So that can be one of the main advantages to select that type of chemistry. Thank you for joining us on today's video tip, and be sure to check out our new chromatography tips next month. If you need help right away, come visit Phenomenex.com. You can look for the live chat where there's experts like me 24/7 to assist you. And once again, thank you and see you next month.